This project topic is semantic multimodality fusion for video search. Basically, video searching is a type of retrieval system extracting useful information through a large database of videos. Nowadays, daily around 5 lakh videos being uploaded, and it's gonna create a huge amount of video data. And with no information on those videos are just as a waste to the database. So we need some data mining algorithm to extract out the useful contents from those videos. So information retrieval is a way of obtaining information relevant to the information resources. So whatever you need from that database, you should able to extract. So you will have input queries and the documents, which would be a data set going to a processor, and then there will be a output, and depending upon the user feedback. So basically in our project we are integrating a user feedback, that is artificial intelligence, so that the network train itself and adjust the weight whether the output was correct or wrong accordingly. Now what is fusion? So fusion is like it is very common example you can see on the screen, where you have RFID card, a biometric and password typing mechanism as a three inputs. You merge them, and basically fusion is multiple things merged together. Here you can see a speed of sound, kind of ideal animal, what you can see. Similarly, in the security system, if you have multiple inputs, it will give a better security. Now in our case, what we are focusing is multimodality. Means for a video searching, you can give image as the input, video as the input, text as the input, audio to the text conversion as the input, and others. So all the parameters will be characterized and information will be fused. That phenomenon is called multimodality, and then at the output you will get the videos. Different inputs we are focusing right now are text combined with the picture, and there could be a video. uh, so I don't know, this dog should have danced. I guess in full screen mode it would dance. So uh, text as an input. So basically if you have speech or a video, and the speech can be in multiple languages, etc., so we finally need to convert it to something that can be done through a operation called transcription, which converts any language, any sentence into English like grammar. Now here we focus only on English to English translation, and it's like a speech recognition algorithm. Mostly this transcription part we are not focusing on, so we assume that there is some transcription algorithm, because that could be a separate project itself, voice to audio transformation, and that's why we take a text as an input, and there would be a transcription algorithm borrowed from some source of MATLAB, or we will just say transcription can be done for a audio input as a source. Now video is like a moving object. Anything that is moving at a faster rate than 1/10 frames per second, you will see on your eye, due to the persistence of vision, a continuous image. Now video is like an input per system as well as our main output, because it's a video search system or video retrieval system, and that's why video is one of the most basic components. It has few aspects like FPS, that is frames per second, should be greater than 1/10, of course. By default it is around 25 FPS, and a resolution. So generally VGA or QVGA, that is 320 cross 480, etc., will be the video sizes we will be focusing on, and it can go up to HD, and nowadays 4K videos are also popular, which could be our output results. Now there are different levels of features. So visual level features or low level features are color, what colors you have, what HSV diagram. HSV is basically hue saturation. So basically that identifies what is the amount of color saturation present, basic color saturation, and colorogram and color auto sync. In texture, it's like wavelet texture, edge histogram, and co-occurrence texture. So basically texture is you have different patterns like straight lines drawn parallel to each other, or perpendicular lines, or a square pattern, checkered pattern. So all these textures, when you transform it into a frequency domain, you will see a specific frequency corresponding to those textures. And local level classifications are mostly for the individual components when you have. Then high level specific visual components are like here we can see we have 4 pictures or 4 videos running, and in which wherever animal is present we increase its corresponding weight to 0.8, 0.7, and since 1 is the input, its weight we set it to 0.2, and then we search wherever there is no animal. So each video is like a node here, and then overall animal present. So each video is a node, and 2 clips are linked with a higher level concept that animal is present. Otherwise, there is no relation between the clips. So out of these 4, we can say these 3 clips are related somehow, but the animal. Maybe there could be another high level concept where people walking and then this animal walking here, and maybe some bird flying and bird flying, they could relate and these two could relate. So that is called high level specific visual concept. So where we are, so we will take a lower level features from images input, we will take high level specific features from a text input, and we somehow multimode fuse it to a mid level systemic concept where we have a low level features as well as high level textual features. And along with that we will do a supervised learning where we will train the machine that this is called elephant, this is called elephant, this is called elephant, this is lion, this is lion, this is lion. We'll ask robot what is this next fellow, and he will either classify it as elephant or lion, and accordingly we will teach him whether it was correct answer or wrong answer, or it could be a third class with a fellow with a question mark, etc. That is called human supervised learning. Once we do a supervised learning, then we pass our algorithm to a adaptive learning. Adaptive learning concept comes from each student should have one guide, but that is not possible because generally you can't have a specific teacher according to the student nature, but you can have specific computer according to the student nature. And with respect to our project, it is like when we have some classes like nature, and in that you have subclass like animal, then it's like very specific systematic semantic operation, and you have a dictionary base which relates if there is an animal, it probably classifies to a nature category, and video can be from nature also, or if there is a storm going on there could be possibility of rain. And so adaptive learning will be there where the dictionary automatically creates links amongst its semantic values, and then the concept based retrieval becomes very powerful. Next is concept driven multimodality fusion. So nowadays these 3D movies are very popular where you have 2 cameras recording the same scene, and then depending upon the phase shift they fuse together. Here you can see one Anilligraph 3D movie where the weight is equal, 0.5 and 0.5, and then you can wear a blue red goggle and see the 3D effect in the same picture. So here equi-weight system we can have non-equal weights where fusion weights are adjusted, so you have x1 to xn systems, and generally the mean is x1 summation x1 to xn divided by n, but we can have w1 into x1 plus w2 into x2 plus w3 into x3, similarly wn into xn, and where w summation can end up at 1 and x can accordingly change its values, and then we get a fused image which is of much more interest. Here we can see MRI and PET scan merged together, and we don't want high significance to a PET scan, that's why we can put like this. Then query concept relatedness. So if you want to search something like in USD, something from United States, something in year 2007, something with respect to purchase of purchase and selling with respect to bike, something in calendar quarter 4. So this number basically relate to all these queries. So we should have query concept relatedness where there is a relation between what query you fire and what answer you should get. That term should be related with respect to query. Similarly, concept modality relevancy is if you say your animal dog, then where it lives, what it eats, etc. could be its relevant values. So while searching, it will connect those values also into the dictionary search. Now these are few literature reviews. We would like to focus on adding a schematic detector for video retrieval and similarly a dynamic multimodal fusion for video searching, representation of key point semantic concept detection. So these are all similar work carried out, query adaptive fusion of multimodal search and selection of concept detectors for video search. So basically, I am reading out the titles. The details basically are given in the description. Problem definition. So we will have basically a multiple input system where we can feed text as a or picture or video.